Okay, some of you had trouble with this homework problem in section 1.3. So here's what we're going to do. We're going to do it and I'll post it so you feel all happy about it. All right. We're going to use sine of 0, sine of pi over 2 equals 1. Wait, sine of 0 equals 0, sine of pi over 2 equals 1, and sine of pi equals 0 to estimate sine of pi over 6. So we're going to use polynomial curve fitting. And so what that means is, because I have 3 pieces of information here, I'm going to go ahead and write 3 different equations using the setup of sine of x, so that's my function, equals a naught plus a1 times x plus a2x squared. I know I need 3 unknowns because I have 3 points, pieces of information that were given to me on this graph. So that's how I know I only have to go up to x squared. All right, so how do I do this? Well, I can say, well, sine of 0, that's my first piece of information given. Well, what's the x? It's 0, so everywhere there was an x in this equation up here, I'm just going to put a 0. So a naught plus 0 times a1, right? And now the reason I switched that is, well, I'll explain it in a second. Here I have a2 times 0 squared. Well, that's just going to be 0 times a2. I'm sure you agree with that. And that's going to equal 0 because that was given that sine of 0 equals 0. Now, sine of pi over 2, in a similar way, I get this equation a naught plus pi over 2 times a1 plus pi over 2 squared, which is pi squared over 4 times a2. Well, what do we know about that? That equals 1. And finally, sine of pi equals a naught plus pi times a1 plus pi squared times a2, and that equals 0. Notice how I've turned things around a little bit. I turned the x's into the coefficients, and what normally were the coefficients I have made into our unknowns. Okay, so I'm looking for a naught, a1, and a2. When I do, I'll substitute those back into this equation and use that equation, sine of x equals a naught plus a1x plus a2x squared, to estimate sine values. Nice, okay? So what we have to do is turn this guy into a coefficient matrix that has been augmented based on these 3 equations. They're going to be my rows. So the first row, I have 1 is the coefficient of a naught, 0 is the coefficient of a1, and 0 is the coefficient of a2, and 0 is my solution to that, or my solution to that row's equation. All right, so similar way, we don't have to spend too long. I get this for the second row, and I get this for the third row. Nice. Now I'm going to use row reduction, which seems like it'll be a pain, but I think you'll see just in a few steps that it works out pretty well. First thing I'm going to do is I'm going to take row 1 plus a negative 1 times row 2 and make that my new row 2. All right, now what's that look like? That looks like this. I get, well, I haven't done anything to row 1, right? I haven't done anything to row, well, I have done something to row 2. What I've done is I'm going to add a negative 1 times row 2. So 1 plus a negative 1 times 1 is 0. And all of these, I think it's easy for you to figure out why, become just the opposites of what we had previously, okay? And finally down here, I don't do anything because I wasn't doing anything to that row. All right, so next step, I claim we can do the same thing to get rid of this 1 down here, but I'm going to say row 1 plus a negative 1 times row 3 is going to become my new row 3. And And there are a billion ways you can do this. This is just what's jumping out at me right now. Again, the first row does not change. This time the second row doesn't change. Now the third row does change. I get a 0 here. I get a negative pi here. I get a negative pi squared here. And then I still get a 0 over here because I'm starting out, I'm working only with zeros. All right, so they don't change when I multiply and add. Okay, but that's looking better. Now I claim if I add negative 1/2 times row 3 to row 2, this middle term will disappear. That's kind of nice. Or I can make this, actually I can make this negative pi disappear. That might be nicer. So what I'm going to do is I'm going to say, well, R2 plus a negative 1/2 times row 3 gives me a new row 3. And what's that look like? Well, it looks like this. Again, row 1 stays the same. And then row 2 is going to stay the same, but I'm going to use it to change row 3. And so row 2 plus negative 1/2 times row 3, well, 0 plus negative 1/2 times 0 is just 0. If I get what I wanted to happen here, I get back a 0 because now this term is going to be a positive pi over 2. And down here I get some weird little term that I'm going to spend some time on. I'm going to come back to, okay? And over here I get just a negative 1 because my R3 term, my row 3 term that I was working with was 0. So now what do I get here? I'm going to do it over here. So I get a negative pi squared over 4 plus pi squared over 2. And I'm adding them together because I was following this recipe right here. Well, if I just find a common denominator, wait, you can't see that. If I just find a common denominator, I say, well, negative pi squared over 4 plus 2 pi squared over 4 is definitely going to equal pi squared over 4. I know you agree with that, so I'm going to go ahead and write that in. Now that's nice, and I'm sure you could tell me why that's nice, because now these two terms, these two entries only differ by a sign. So guess what? I'm going to add row 3 to row 2, and I'm going to make a new row 2 by doing that. So row 3 plus row 2 is going to become my new row 2. Good. All right, so I'm not going to spend too much time talking about that because that's super easy. And I think I get that. Let me just check it. Do I get that? I sure get that. So now all I have to do is, see these? I just have to turn this entry and this entry along the diagonal into 1s. That is really easy. I'm just going to, on this step, I'm going to divide row 2 by a negative pi over 2. So 1 over a negative pi over 2 times row 2 becomes my new row 2. And at the same time, 1 over pi squared over 4 times row 3 becomes my new row 3. Notice how I'm showing all the steps even though they're easy. Some of them are super easy, right? Just showing all the steps. Okay, so what I get back here is 1, 0, and if you think about it for a second, you're going to get 4 over pi. If I divide negative 2 by a negative pi over 2. I'm sure you can see that. In a similar argument, down here, I get a 1, and then I'm going to get a negative 4 over pi squared. Now that looks kind of kind of ugly. But here's our goal. Over up here, we were trying to find A0, A1, and A2. Well, I just found them. Look, A0 is equal to 1. That's easy. A1 is equal to 4 over pi. And then A2 is equal to a negative 4 over pi squared. That's great. Now, why is that great? Let's actually go up here to finish the problem. I'm gonna rewrite this equation as sine of x equals, well, 0, so I'm not gonna write anything. 4 over pi times x plus a negative 4 over pi squared times x squared. I'm sure you agree with that. And so now all I have to do is, I can use this any point to estimate the sine of that point, but it just so happens that they wanted us to use pi over 6. So this is where my final answer is going to be. Sine of pi over 6 has to equal 4 over pi times pi over 6. We'll come back and deal with that in a second. Minus 4 over pi squared times pi squared over 36. Look what nice things happen. So the pi's cancel, I get 2/3, minus the pi squares cancel, I get 1/9. Okay? Now, what if I want to go ahead and simplify this? Well, first we'll do that. I get, what, 4, no, 6, boy, I'm smart, 6 ninths minus 1/9 is just 5/9. Okay, so that's what you should get. Now you're in the homework on WebAssign, they wanted, here's my handy calculator. They wanted you to put in a decimal, so let me show you what, and round it to 3 decimal places. So 5/9 is almost equal to 0.556. And you might have been asked different points, because I think that was part of the assignment that could change. But if you were asked to find the sine, or estimate the sine of pi over 6, then sure enough you would get 0.556 rounded to 3 decimal places. I hope that helped you. And yes, indeed, the sine of pi over 6 is 0.5, so that is a pretty nice approximation with just 3 points to approximate. All right, I hope this helped you, and please continue to ask me questions about specific homework problems so that I can go ahead and post them to try to help you out.